Hello everybody, Salkan here and welcome to Games with Python. Today we are going to talk about the Tower of Hanoi solver using recursion. We'll start off with an introduction which includes the thought process on creating our code in a Python script. If you wish to skip to the coding part, which I suggest you shouldn't, you may do so by checking the timestamps in the description. The Tower of Hanoi is a mathematical game or puzzle consisting of 3 rods and a number of disks of varying sizes. In the Tower of Hanoi setup, it usually begins with disks stacked on one rod in decreasing size, with the smallest disk at the top of the stack. The objective of the puzzle is to transfer all of the disks in the stack to a destination or target rod, but with the following constraints. First, only one disk may be moved at a time. Second, each move consists of taking a disk from the stack and place it onto another rod. And third, a disk must not be placed on top of a smaller disk. The puzzle is fairly simple when solved manually. However, as the number of disks increases, the game becomes more tedious and may probably deviate from the correct solution along the way. The solution to this puzzle actually follows a repetitive pattern, and what better solves repetition is with recursion. A recursive function is a function that calls itself, which, when used properly, results to a neat, concise, and readable code. Let's start with a very simple state of a Tower of Hanoi puzzle, where there is no disk. Since there is no disk to move, then we do nothing. Puzzle solved. Let's up the game a little bit. What do we do if there is one disk in the puzzle? Well, we simply transfer that disk from the source to the destination. Puzzle solved. Well, how about a puzzle with 2 disks? We can't move disk 1 to the destination, followed by disk 2, because then disk 2 will be on top of disk 1, which is a violation to the third rule of the game. The simplest way to solve this puzzle is to move disk 1 from the source onto an auxiliary rod temporarily, then move disk 2 from the source onto a destination rod. This shall address the third violation we could have had. Finally, we move disk 1 from the auxiliary rod to the destination rod. Puzzle solved. I'd also like to emphasize that in solving this puzzle with 2 disks, we actually solve them by moving one disk at a time. Now how about a puzzle with 3 disks? Well, the solution is actually a lot longer than ordinary, with 7 moves to be precise. I'll skip the minute details and simplify the solution. To solve this, we simply move the top disks 1 and 2 from the source to the auxiliary rod, and then move disk 3 from the source to the destination rod. Now, you may object, saying that we are violating the first rule of the game, where we move disks 1 and 2 at once. Well, visually, yes, but technically, no. Remember that we had previously solved a puzzle state with 2 disks from the source to the destination by moving them one disk at a time. This is actually where the recursion part of the solution comes in. In essence, we use the recursive function to move disks 1 and 2 from the source to the auxiliary rod one disk at a time, and not as a group. If you still don't get this part, then you may want to review the state where we had only 2 disks and see that we are actually moving them one disk at a time. And to finalize, we can transfer disks 1 and 2 from the auxiliary to the destination rod. Again, with the use of a recursive function, we can move these 2 disks one disk at a time and not as a group. Last example, just so we can completely grasp the pattern, we have 4 disks. The solution is to move the top disks 1, 2, and 3 from the source to the auxiliary rod, then transfer the disk 4 from the source to the destination. Again, with the use of a recursive function, we are not moving the top 3 disks at once, but one disk at a time. Finally, we then transfer the disks 1, 2, and 3 from the auxiliary rod to the destination on top of disk 4 using the recursive function. Now, let's summarize the solution. For a puzzle with no disk, we do nothing. For a puzzle with one disk, we transfer the disk from the source to the destination. As for the puzzle with disks more than one, we notice that they actually follow the same pattern, and that moving the top disks are solvable if you just reference them to their previous row. We now come up with a pseudocode, which is simply the summary we've had generalized into a solution. We basically have three cases: no disk, one disk, and multiple disks. And with that, we are finished with the introduction. Now, onto the code. The first thing that we want to do is to define a recursive function to solve the Tower of Hanoi puzzle. Let's call it solve Tower of Hanoi with recursion. The function will take in disks parameter, which is the number of disks given at the start of the puzzle. We will also consider the source rod, which is from where the disks are stuck initially, then the destination rod to where we want to transfer the disks, and the auxiliary rod to hold the disks temporarily. What we expect this function will do is to give us instructions what disk to move and from where and where to. Now, from our pseudocode, we will be considering the three cases where the first case being or having no disk, the second case having one disk, and the third case having n number of disks, and we'll solve them one by one. So for the first case, that is for disk equal to 0, then we're simply gonna do nothing. And in Python, the way to do nothing is we can use the return statement, or we can use the pass statement, whichever you prefer. And just for safety measures, we can use the less than or equal condition here, just so we could handle negative values for disks. Now let's check for the case with one disk. And what we want to do here is we are simply going to move the disk from the source to the destination, and let's just give an instruction as a print statement using an F string, and I'm going to explain it in a moment. We're just going to give an instruction here, and disk source to destination. So what an F string does is it is actually a string preceded with an F to indicate an F string, and wherever if we find the curly brackets inside the string, is going to evaluate that variable or value into a string. So for this case, when we have disk 1, this will be ability to move disk 1 from whatever source is to whatever the destination is. And that's it for the case of one disk. Now for the case of multiple disks, that is there are more than one disk, then we're simply gonna use the else statement, since the case where for negative number of disks in 0 and disk equals to 1 are already taken. And yeah, so the first part of the solution here is to actually move the top disks from the source to the auxiliary rod, and moving several disks like this is just another form of the puzzle. Thus we'll be calling the recursive function for this. And so let me just call in our recursive function, and our recursive function is gonna take 3 or 4 parameters. So the disk being the top disks, this disk minus 1. So say for example we have 4 disks, this disk minus 1 is this disk actually going to be 3, and then the source is where this top disks comes from, and this will be the source, and we'll be transferring this disk to the destination, but this time the destination will be the auxiliary rod, and the auxiliary rod will be the rod that we haven't used yet. So for this case we have used the source in the auxiliary, so our auxiliary rod now will be the destination rod. And after moving the top disks from the source to the auxiliary, we are now going to move the nth disk from the source to the destination, and we'll simply do that with by giving an instruction using an print statement and using the f string. So let me just copy this and give that the same example. And lastly, after moving that, then we're going to transfer back the one that we have transferred to the auxiliary, and we're going to place it on top of this disk which is already in the destination. So to do that, we're going to call the recursive function to transfer all of the disks that were already in the auxiliary. So we're going to pass in the disk minus 1, which is essentially just the one that we have transferred to the auxiliary, and we're also transferring them just as the same, and pass in the source. The source now, however, is from the auxiliary, since this stack is the top disk stack is already on the auxiliary, and the destination will be placed. The destination should be on top of this disk, and the auxiliary rod is going to be the rod that we haven't used. So we have now used the auxiliary in the destination. Now the auxiliary will be the source rod. And with that, we're simply done with our recursive function. Let's try and test this function out. So we're going to call our recursive function, pass in some test values. Let's start with a disk of 0, the source, let's say rod A, and the destination being rod B, and the auxiliary being rod C. And let's try and run this. Then we see that it's actually doing nothing, just like so. And so if we try the disk of 1, then we'll see that it transferred the disk right from the source onto the destination run. And if we try the disk of 2, then we see that we have transferred the top disk from the source to the auxiliary, and the auxiliary, or the disk 2 from the source to the destination, and then the top disk from auxiliary to the destination. And we can also try for the disk 3. Then we see that initially we have moved the top disks 1 and 2 from the source to the auxiliary rod, and as you can see here, we are actually moving them one disk at a time, and then move disk 3 from the source to the destination, and then move the disks 1 and 2 from the auxiliary back onto the destination run. And you can check for the 4 disk as well and see that you have a solution, and you may also test it out with several more disks like so. And that marks the end of this video.